I'm Anil Kumar discussing with you previous test paper from one of my IB student. We'll now discuss about horizontal and vertical asymptotes. Here is a question from the test paper, question 2a. Determine all asymptotes for f of x equals to x square minus x minus 2 divided by 2x square plus 2x. Now, since the degree of numerator and denominator is same, we have a horizontal asymptote, which is the x-axis, y equals to 0. Right? Let us also prove it by finding the limits. Okay, so we have f of x as equal to x square minus x minus 2. Let me rewrite this: x square minus x minus 2 divided by 2x square plus 2x. Now, those of you who know the rule, they can actually directly write down the answer. Anyway, let's factor out x square from the numerator. So we get 1 minus 1 over x minus 2 over x square, right? In the numerator, denominator, when you factor out 2x square, you can factor out, you get 1 plus 1 over x. So that is the function f of x. Now, at this stage, we can find the limit. So to find the horizontal asymptote, we should find the limit when x approaches, let's say, infinity or negative infinity for the function f of x, right? So that gives you the horizontal asymptote. So if I write limit, we are applying the laws of limit here. X approaches, let's take infinity, and here we have limit x approaches infinity for 1 minus limit x approaches infinity for 1 over x minus limit x approaches infinity for 2 over x squared. So we applied the rule, sum and difference rule, right? And this is the quotient rule now applied. So we have limit x approaches infinity for 2x squared and limit x approaches infinity for 1 plus limit x approaches infinity for 1 over x, correct? Now, as you know, for 1 it is going to be 1, but 1 over x, as limit is very infinity, it will be 0, this will be 0. So these limits are 0, right? These limits are 0. So these limits are going to be 0, right? These are zeros. This one is 0, this is 1, correct? So what we get here is limit of the function. I forgot, let's cancel this limit. This is 2 times x squared, right? So x squared, let me rewrite this. So x squared and x squared will cancel out. So what we could do here before finding the limit is we could cancel x squared, correct? So that really simplifies a bit. So we get limit of 2 here, right? So basically what you get here is half. Since this is 1 plus 0, you can say 1 plus 0. And this is also 1 plus 0. So the limit is half for the function, and therefore we can write down that the horizontal asymptote is at y equals to half, correct? That is the difference as the leading coefficients, right? So quotient of leading coefficients give you the horizontal asymptote equation when the rational function has same degree of numerator and denominator, correct? So that is the horizontal asymptote. Now let us check if we have some vertical asymptotes, right? So let me just divide this page a bit and we'll check now vertical asymptotes. So for that, let me factor the function. So let's use the space. Okay, so we have f of x equals to, let's factor the numerator. Minus 2 is the product, sum minus 1. So we can write x minus 2 times x plus 1 in the numerator. We can factor 2x. And we get x plus 1 in the denominator, right? So that gives us a whole at x minus 1. So we have a whole at x equals to minus 1, right? And this gives you a vertical asymptote. So we have a vertical asymptote at x equals to 0, right? So that gives you vertical asymptote at x equals to 0, correct? So now we can write down our answers. Answers are horizontal asymptote is at y equals to half, vertical asymptote is at x equals to 0, and whole is at x equals to minus 1, correct? So that is how you can actually solve this question. Well, for some of you, if this is like too tedious, then you could think at this stage, if x is very large, then these two terms are 0, this term is also 0. So you're left with 1 in the numerator, 2 times 1 in the denominator, so half, which is the quotient of leading coefficients, right? So half. So you could get directly also. I hope that helps. Thank you and all the best.